The fascinating life of moths, from nocturnal navigators to ecological wonders. Moths, often overshadowed by their butterfly cousins, lead complex and remarkable lives that are integral to ecosystems worldwide. With over 160,000 species, their life cycles, migratory behaviors, and ecological roles reveal a world of adaptation and survival. This article explores the unique aspects of moth biology, from their metamorphic life stages to their extraordinary navigational abilities and their responses to environmental challenges like climate change. The life cycle of moths, a journey through metamorphosis. Moths undergo complete metamorphosis, transitioning through 4 distinct stages: egg, larva, caterpillar, pupa, cocoon, and adult. Egg stage. Female moths carefully select host plants to lay their eggs, using sensory organs on their feet to detect suitable surfaces. Some species, like the clothes moth Tiniola basileella, lay eggs on keratin-rich fabrics, while others target specific plants. Egg development varies with temperature and humidity. Some hatch in 3-4 days, while others take weeks. 1114. 2. Larval stage. The hungry caterpillar. The larval stage is the most destructive and growth-intensive phase. Moth caterpillars, such as the invasive spongy moth Lymantria dispar, can increase their body mass 100-fold in just 2 weeks by voraciously consuming leaves or fabrics. 14. Some species, like the alpine silver Y moth Syngrapha autolangui, prolong larval development to survive harsh winters. 8. Clothes moth larvae can remain in this stage for up to 30 months, silently damaging wool and silk. 11. 3. Pupa stage, transformation in secrecy. Before pupating, moth larvae spin silk cocoons or burrow underground. Inside, their bodies dissolve into a gunk of cells through histolysis, reorganizing into adult structures. This stage can last from 8 days to several years. Arctic woolly bear moth Scynophora groenlandica extend pupal diapause up to 7 years to survive extreme cold. 14. 4. Adult stage, a brief but vital phase. Adult moths prioritize reproduction. Many, like the Luna moth Actius luna, lack mouthparts and live only a week, relying on stored energy. 14. Others, such as migratory hawk moths, live longer to complete journeys. Females emit pheromones to attract mates, while males use antennae to detect these signals over miles. 11. Migration and navigation. Masters of long-distance travel. Unlike birds, most moths migrate one way across generations, but their navigational prowess rivals any vertebrate. 1. Internal compass and wind adaptation. The death's head hawkmoth Acherontia atropos migrates from Europe to Africa, maintaining straight paths despite shifting winds. Researchers found they use an internal compass, possibly combining celestial cues and Earth's magnetic field. 3. Some species, like the silver Y autographa gamma, correct their flight paths mid-journey using magnetic fields. 6.2. Celestial and landscape cues. Moths use the sun, moon, and polarized light for orientation. The bogong moth Agrotis infusa navigates to Australian alpine caves using the Milky Way 6. Coastal lines and mountain passes also guide routes. Hawk moths avoid alpine peaks, opting for valleys. 3.3. Multi-generational migrations. Painted ladies Vanessa Cardui span continents over generations. In 2019, a population from Arabia reached Europe in 3 generations, aided by tailwind 6. Similarly, monarch butterflies, a close relative, migrate 3,000 miles annually, though no single moth species replicates this feat. Ecological and evolutionary adaptations. 1. Camouflage and natural selection. Peppered moth Biston betuliaria exemplifies evolution. Industrial soot darkened tree trunks, favoring melanic moths over light-colored ones. After air quality improved, pale moths rebounded, a classic case of natural selection. 12. 2. Climate change response. Himalayan hawk moths, studied in the documentary Nocturnes, face habitat shifts due to warming temperatures. Researchers observe how altered humidity and temperature affect their breeding cycles. 410. Some species, like the boxtree moth Sidalima perspectilis, now produce extra generations yearly in warming climates. 8.3. Pollination and pest roles. While some moths, for example clothes moths, are pests, others pollinate night-blooming plants. The yucca moth Tageticula co-evolved with yucca plants, ensuring mutual survival. 14. Conversely, the diamondback moth Plutella xylostella devastates crops but showcases resilience by migrating 3,000 kilometers annually. 6. Conclusion. Moths as indicators and innovators. Myths are ecological barometers, reflecting environmental health through population shifts and adaptive traits. Their life cycles, migratory strategies, and roles in pollination and pest control underscore their importance. From the Arctic woolly bear's 7-year larval stage to the death's head hawk moth's transcontinental flights, moths exemplify nature's ingenuity. As climate change alters habitats, studying moths' weather in Himalayan forests or urban gardens offers insights into resilience and survival in a rapidly changing world. 31,014. Key takeaways. Moths undergo 4 life stages, with larval phases lasting months to years. They navigate using magnetic fields, celestial cues, and landscape features. Climate change is altering migration patterns and life cycles. Their ecological roles range from pollinators to pests, shaping ecosystems.